Welcome back to Understanding Python. My name is Jake, and today we're going to learn about string manipulation, from URL construction to user input handling, data processing, and more. String manipulation is one of those core skills that every Python programmer must know. So stick with me and we'll add a major skill to your toolset. As we go, if you learn something new, let me know by liking the video. One important thing to keep in mind during this video: in Python, strings are immutable. This means we can't change the original string, and we will only be able to store the results of some operation on them. This is why everything we will do will either be immediately assigned or printed out. Let's start today with string concatenation, which is just a fancy way of saying add two or more strings together. In its most simple form, it can be as easy as literally adding two strings. For example, adding the two strings hello and world together will result in the new string message, which we can print out. And if we run that, we see hello world. Easy enough, right? Not only is this form of concatenation in scenarios like this easy, it's actually faster than the other alternatives in Python using formatting. As long as it's simply adding strings together, using the plus here is perfectly fine. Now, it of course works with the strings that we're creating here, and we can also override our current message by adding in another new string. We run that, we see our original message and then our modified message below it. Now there's another common form of concatenation that we can use, which operates a bit differently, and this is largely seen when acting on some type of iterable. For example, this list of strings. And say we wanted to add these lists of strings together, of course we could iterate through it and can compose a string from that, but there's an easier way to do it in Python. And that is simply by joining some iterable. Now this syntax might look a little strange, so let's print it out first and then we'll explain what's going on. Okay, here in this last part we see I can be put together. But what do you notice about this? There's a space in between each of these words, just like you'd expect in a normal sentence. That's because we joined on an empty space here. So in fact, we're joining this list of strings together with whatever this string is as our glue. And you can really make this whatever you want to be. So if we come up with two more examples, and we'll just name these join 2 and join 3, we'll put a comma and then a space for join 2. And for join 3, we'll put a new line character and then print each of those out. Give ourselves some more space and let's run it again. And here we go. We see our original join with the spaces in between. We see our second join with a comma and a space. And finally, we see our third join with new line characters in between each of those. And you can really make these whatever you want them to be, as long as it's a valid string. But one important thing to keep in mind is that each item you're joining has to be a string. So be sure to handle conversions when needed. Okay. Now it's time to take a look at formatting strings. And as you're about to see, Python has many ways to format strings. The first of which, and the one I think you should be using in probably 95% or more of your cases, is f-strings. And that's because in modern Python, the cleanest and fastest way to format strings is with f-strings. And to create an f-string, we simply just start with the letter f, and then we define our string. And in this string, you'll see something new, which is these curly braces. And in the curly braces, we can put things like variables in there. So the value of domain up here on line 3 is going to be injected or formatted into this new string. And of course, we're going to need to save this. And now we have a new URL string. And if we run this, we see it puts it together. And just for completeness, we'll also put the trailing slash at the end, so it looks like a full URL. Pretty easy, right? Editor Jake here. As you watch this video, if you notice something is a little bit different, that's thanks to this comment from Blanky Nap, who recommended I check out Starship for shell customization. And after trying it out for a week or so, it's officially replaced Powerline, which I've been using for many years. So thanks for the recommendation. Now, not only can you eject variables, but you can also evaluate expressions and have the result of that inserted in the formatting. So for this example, I want to print out the number of items that are in TList. Now, of course, I can always run length oftlist and get the value, but I can also take that out here and just run that within the f string itself. So when this string is constructed, it's going to run the length of tlist and put the value of that into the string. And we see here the result of that operation. Okay, let me write out a little bit of a more complex example. And I mean it when I say this is a more complex example. So maybe to better help understand this, what we should do is run it first and see the result. And here the sentence reads, there is one item in tlist. So this solves a few of the problems we had in the previous example, where I said there are one item or items in tlist, which isn't correct grammar for the English language. It should read there is one item in tlist. And we can handle this by doing more of these expressions in the string formatting itself. So on line 10, we got the length of tlist. This is because we're going to be using it multiple times in the following string. Then we construct our f string. And in here, we have a few different expressions that are going to change depending on the value of tlist. So we can either have the value of is or are here using an inline if statement. So if the length of tlist is equal to 1, then we'll use the string is. Otherwise, if we're bumped up to 2 or more, or technically any other non-1 value, we'd have the string are. After that, we put in the actual value of tlist, followed by item, and again checking the length of tlist. We're keeping this here as a reminder that we can do expressions. And following the same pattern as before, if it's equal to 1, we don't put anything there. So it'll just be item. Otherwise, we're going to pluralize it with an s. Okay. Now, if we were to add things on to tlist, say 2 and then 3, and run it again, we see our second string changes, saying there are 3 items in tlist, as well as our prettier version of the string, there are 3 items in tlist. There's a lot more we can do with formatting, but first we need to get to the other 2 methods. Before f-strings came onto the scene, the format method was my go-to, and in some cases, it is better choice than f-strings. So let's take a look at that. Here we'll overwrite the value of domain to be redhat.com, and we're going to construct our URL again. This time, we're not going to put anything at the beginning of the string, but we are going to use that curly brace notation again. And how we're going to get the value in there is we're going to use the strings format method, putting in the value of domain. And for now, I'm going to comment out the previous prints just to keep things clean. Okay, so if we print out URL now, much like before, we see that formatted URL. Pretty easy. Although just comparing these two, you can see that the f-string version is significantly cleaner. But unlike f-strings, there are multiple ways that we can handle formatting with the format method. So if we add a few more components to our string, we can start constructing a few more URLs. So to put these together, I'm going to put those curly braces, then a colon with double forward slash, more curly braces, followed by another forward slash, and a final curly brace. If we call format here, we can pass in each of these: protocol, domain, and finally path. And we can also print that out. And if we run it, we see it puts all of those together, just as we'd expect. But we can also mix things up a bit. And we can switch it up positionally by using the second form of formatting, where we put in the position of the arguments that you'd accept to be passed in the string itself. So here, instead of protocol being passed first, as it was in URL 1, we see being passed in the second position, or the 1 index. Domain is in the 2 index, and then finally path is in the 0 index. To verify that works, we'll run it again and see we have the same result. A more common but verbose way of putting this is to pass things by keyword argument. And here the string on the left is starting to resemble more of what you'd see with an f string. However, we still have to pass those arguments into format, so we're going to specify protocol, domain, and path what we pass in. These have to match what you see on the left-hand side here. If we run that, it looks exactly the same. But again, make sure that it matches. So if we change this to proto, dom, and pth and try to run it, it's not going to work. So we need to get that to match proto, dom, and pth. We run that one more time and it's happy again. Okay, so I said before that there are cases where I would use format over f strings. So let me show you what that looks like. And this case is going to be inspired by a real use in one of my projects. Okay, so in this example, we have something that's fairly typical for a subsection of an API response. And what we want to do is we want to put the owner information together in a single string. If we look at the f string version of this, it's kind of hard to follow what's going on because there's so much packed into a single line. You can't really tell too much of what this side of it is, or really this side. We just know that it's going to be the display name and then the email address. However, if we look at the f string version of that, we can see more clearly what the resulting string is going to look like. And while it's more verbose, to me, it's more clear exactly what's going on. And as you'd expect, the result of both strings is exactly the same. So while this largely comes down to personal preference, in a situation like this, I prefer the format method over f strings. But there's yet another format method that Python provides. And this last formatting method is commonly referred to as percent formatting. It's the oldest remaining special form of formatting that I know about in the Python language. And while it's much less commonly seen in modern Python code, it is still seen with many logging systems. So if we put this together into a new string, we'd start normally as you would with others, except for instead of using that curly bracket notation, we're going to put a %s in here. And then we're also going to include the age, which is going to be %d, and then finally the occupation with another %s. Now note how the formatting notation also indicates the data type with string and decimal or digit data types. Now, of course, just like the others, we need to tell Python where these values are coming from. So to do that, we're going to use another % here, and we'll pack those values together in a new tuple for name, age, and occupation. And finally, we can print our person. And if we print it out, we see name, James, age 35, occupation, engineer. Comparing this to f strings, we see the f string is a little bit smaller and, in my opinion, a bit more readable. Okay, I teased it before, but there's a good amount that we can still do with formatting, and we'll call this section special formatting. So say, for example, you have some type of number, and it's not just 1, 2, 3, 4, it's also decimal 5 through 9. Let's play around with this a bit more. First thing we can do with f strings is we can say number with the equal sign here, and when we run that, we see something interesting. We not only see the value of number, but we also see number is equal to printed out as well. For those of us that sometimes resort to print debugging, like I'll confess to, this is a really nice thing to have. We can just put in some variable name with an equal sign, and it'll print out both the variable name as well as the value. Really nice to have. But what if we didn't want to print out all of this when we are presenting to the user? Well, for this, we'll print out a new string, again formatting in number, but this time we're going to use a new notation where we put a colon and then a period, the number 2, and then f. And if we run this, we see something interesting. We see that Python caps it and specifically rounds it appropriately to 2 decimal places. So with this formatting, we're telling Python after decimal point, give us 2 additional characters. Pretty nice, right? But we can also step it up a little bit more. And we can do that by putting a comma before that period. And if we run that, we see even better formatting because it adds that comma in there appropriately at the thousandths separator. This is really good when you're working with numbers and especially monetary values. Okay, now let's mess around with strings a bit more. And for this, I'm just going to put the value up there. And let's see what happens when I run this. If we look at the resulting string, we see hello with some extra spaces in here. 5 additional spaces to be exact. And that's because hello has a string length of 5. We're telling Python we want to left align the value of this expression in here, and it should have a total of 10 characters in there. So it's going to add additional 5 characters of padding to the right hand side of that string. Not only can we left align it, but we can also right align it, and we can center align it. Here in center, we see 1, 2 on the left hand side and 1, 2, 3 additional spaces on the right hand side. Pretty handy, right? Okay, and for our last example in this section, we're we're going to need to pull in datetime from datetime. We'll get now real quick. And because typing these formats can be a little bit annoying, I'm going to take them out of the oven. Okay, this might look a little wild, but we're basically just formatting now with the specific datetime format. In the first example, putting in the year, month, and day, followed by hours, minutes, and seconds. And then the second one, just printing out what today is. So if we run this, we see current date and time is right here, and current weekday name is Friday, which can come in handy in a number of situations. But you can use any datetime formatting that you want here. All right, let's move on from formatting. One very common task you'll encounter is the need to break a string into substrings. My favorite way to do this is to use the split method. And the way we're going to use this is we're going to take our original string and call .split on it. And if we run this, we see that it took that sentence and broke it down into individual words or individual substrings and put them all into a list. The default behavior of split is to break the string into a list of substrings whenever it encounters white space. Hang on a minute. What does Python consider to be white space? Well, luckily we have an easy way to tell. In IPython, we can import string, which is a module that has some interesting things with it. And included in there is white space, which is any kind of empty space, a tab, new line character, return character, and then these special Unicode characters. So even if our sentence had a new line character in there and we run it, it has the same effect. Not too bad. Well, while splitting on whitespace is handy, you can specify any separator to split on, whether that's a single character string or any other valid string. For example, we can split on test. Running that, we see this is and notice how the new line character is preserved because we're not splitting on that now. Then we see test is missing, followed by a blank space, and then sentence, which is the rest of the sentence. Additionally, if we were to split on the beginning of a sentence, this is what the result looks like. Notice how the first substring is empty. That's because what we separate on is removed from the string. So our substring here, this is A, has been removed from that first separation. And since this is the only contents in the beginning of the string, we're left with an empty string. But what if we were to split on something that isn't in the string? Well, let's try that with this missing split. Here we're trying to split on a comma with a space in it, and that doesn't exist in the sentence. And here we see it's still a list, but with the entire sentence intact. And that's because that separator was never encountered. Let's put two concepts we've covered together in a single example. We can combine split and join to restructure the format of a string. So what I want to do here is to remove the spaces from the movie file names and replace them with underscores, which is easier to deal with when using a CLI. There's an easier way to handle this, but we'll get to that a little later on. For now, what we can do is iterate over each movie in the movie files list. We can split the file name by using movie.split. That will remove all of the spaces in here, and that'll give us the individual substrings outside of the white space. We can then join the file name back together on an underscore by calling .join on split file name, and finally print out join file name. And if we run this now, we see it has that format that we're looking for. And the nice thing about that is it doesn't need to reformat things that don't have spaces in it. But now we have those nicely formatted file names that work a lot easier with command line interfaces. Okay, let's move on from splitting. If you're working in data science or an adjacent field, you've likely had to clean a lot of data. Even if you're not doing data science, you're almost certainly going to have to clean strings you get from APIs, CLIs, and especially users. The first and most simple method for cleaning strings is strip. This will act on the beginning and end of a string, removing unwanted characters. So here we have a dirty string, and we want to create a new strip string by acting on dirty and calling, as you may have guessed, strip, which we can then print out. And here you see a nice and clean string. with no additional white space before or at the end of the string. Not only can you remove white space, but you can also specify any characters you want removed by passing that to strip. So we want to strip more things. We'll again act on the dirty string. And this time we're going to call strip, but we're going to pass in something different. We're going to put back in that empty space as well as new line characters, but I also want to remove that period from the string. And if we print out more stripped here, you'll see that it again cleans off that extra white space that we specified, but it also takes care of that period. And we can add on as many characters that we want to clean in here as well. Say we wanted additional punctuation, or if we wanted to remove things like even individual characters, we could do that as well. Here we added in A as well as G, and those have been stripped from the string. It's really up to you of what gets removed. Now, strip is great, but what if you want to remove or replace things not just from the outside of a string, but also throughout the string? For that, we turn to replace. Say for example, we wanted to take that dirty string and strip out all spaces from it. Well, we'll call dirty.replace, and in here the first position is going to be what you want to replace, and the second position is what you want to replace that with. So in my example, I want to replace all substrings that are just an empty space with a substring which is empty. And if we print this out, we see the result. And you might be thinking, why is there space here? That's because it's not literally this substring here, which is an empty space. It's actually a tab character, which is why we have that extra new line character here as well at the end of the string, because we didn't replace that. Now, not only can we do simple substitutions, we can also replace any substring with any other substring that we want. It's entirely up to your needs. We can even rewrite that string by doing a more in-depth replace, removing example and that tab character, and replacing it with a new substring that says perfect example. And we'll again print that out. And here you see the result at the end, which we can tweak a little to add an additional space right there. And I'll bring that dirty string into frame as a reference. So we have that leading space here at the front of the string. We've replaced that example with the tab that we saw before, instead of replacing that with perfect example, and then followed up by string again. Again, remember with replace, you can replace anything within a string that you want with anything that you want. Now there is more to replace, specifically an argument for count. You can replace the first number of occurrences instead of all of them throughout a string if that's what you want. Say you just want to replace the first thing, you can do that. And for strip, it also has alternatives for L strip and R strip, to strip explicitly from the left or to strip explicitly from the right. But these are the more common usages of both. Okay, let's take this chance to revisit the movie example from earlier and use replace to simplify the code. We'll still use a for loop, but this time, all we need to do is print movie.replace, and we're going to replace those empty spaces with an underscore. And that's it. There are a ton of things you can do with string manipulation in Python, but in the interest of time, we'll stop with these core skills. Use them to build upon and develop yourself as an expert string manipulator. As always, today's code will be added to the Understanding GitHub repo, so check the description for a link. And of course, if you have any questions or suggestions for topics you'd like me to cover, leave a comment for me. To keep up with this series, please consider subscribing. Thanks for watching.